Hello, and thank you for joining us at Coalesce. My name is Livia Bussini. I'm a Regional Director of Solutions Engineering at DBT Labs, and I'll be your host for the session. The title of this session is Move Fast and Don't Break Things, Testing DBT Models with Bigeye, and we'll be joined by Egor Gryaznov. Egor is co-founder and Chief Technology Officer at Bigeye. He enjoys training for triathlons, used to be a swimmer, and now he's learning how to bike and run. Spending time with his 2 months old newborn is what he does for fun these days. Before we dive right in, I just wanted to share a couple of recommendations on how to get the most out of the session. All chat conversation is taking place in the Coalesce Move Fast and channel of DBT Slack. If you're not part of the chat, you have time to join right now. Visit getdbt.com/community and search for Coalesce Move Fast and when you enter the space. We encourage you to ask other attendees questions, make comments, or react at any point in the channel. After the session, the speaker will be available in the Slack channel to answer your questions. However, we encourage you to ask questions at any point during the session. Let's get started now. Over to you, Egor.
Great. Thanks a lot, Livia. Thank you, everyone, for joining my talk. Today, we're going to be talking about moving fast and not breaking things and how you can use both DBT and Bigeye in order to ensure stability in your data model changes. So first, a little bit about myself and Bigeye. As Livia has mentioned, I am the co-founder and CTO here at Bigeye. Before Bigeye, I was a staff engineer at Uber, where I was one of the first people called a data engineer. My team was responsible for the first data warehouse, moving Uber from Postgres replicas to Vertica, and building out all of the tooling necessary to support it. Interestingly enough, DBT did not exist back then. I really wish it did. It would have made my life a lot easier back in 2015, but I am glad that all of you are able to use great tools such as DBT and Bigeye nowadays. So let's move on and talk a little bit about Bigeye. So Bigeye is a data observability product. We help data teams find and prevent problems in their data by monitoring their data proactively and notifying teams whenever something is wrong with their data. Now, this proactive notification is great once the data is already landed and once we can monitor it in your warehouse. But what about when your data is changing, when you're updating your models and you're doing something in order, you're making some business logic changes, maybe you're dropping a table and you're replacing it with something else, and you need to know what is actually going to change and what's going to happen. Well, there's not a lot of tools for that, and we at Bigeye have built a couple of interesting features that you can integrate with your pipeline to build proper CI/CD for data. And in this case, CI/CD stands for continuous integration and continuous deployment, making sure that any changes are constantly being tested against what production would look like, as well as constantly being deployed. DBT does a great job of doing the CD part, and let's talk a little bit about the CI part. So if you've seen any of my other talks, you've probably remember this chart. I talk about this quite a bit, how data engineering is evolving. If you look at the path that software engineering took a couple of years ago, there was a real change when software engineering, when cloud infrastructure came out, and building software and deploying software became a lot easier. You didn't have to manage your physical machines in a closet somewhere, which I remember installing servers into racks at some point. And this made it a lot easier for somebody to go and spin up a server, deploy an application, get something running, get an API up, and build software. Because now there's so much software, now tooling around deployment automation and testing and integration came out. So I'm talking things like Jenkins and GitHub and GitLab and all these tools that help you manage your code and have functionality around deploying it and pushing it out to production. And finally, now that all this stuff is running in production, monitoring and observability in the form of Datadog, New Relic, App Dynamics, the like, came out in order to give software teams and engineering teams more visibility into what is actually going on with their production applications and whenever something looks wrong. So data engineering follows a very similar path, but the concepts are just slightly tweaked for the data world. Instead of cloud infrastructure, we talk about cloud warehouses. So many of you are using probably Snowflake, BigQuery, Redshift. These are very easy to set up databases. I go and I swipe a credit card and I have a Snowflake instance. It phenomenal. This was not the case back in 2010, 2000 at all. That back then it was install a warehouse on a physical machine. Because it's so easy for us to get the cloud warehouse infrastructure set up, now it's easy for us to get data into it because I don't have to worry about managing and scaling on my warehouse. I can push as much data as I want from as many sources. Fivetran helps make this very easy, and dbt helps me transform that data into something that's actually usable. And so these platforms help you create a lot of different data sets for your business to use. And that's great because now your business has this unprecedented access to information from across the whole organization. And they can make rapid decisions on it. They can iterate, they can build machine learning models and new kinds of reportings, maybe find out new lines of businesses that they should pursue. But all of this comes at a cost. And the cost is maintaining the sanity of the data team around scaling all of these different data sources and different data pipelines. With dbt, it's exceptionally easy to go and create a new model for something, go and update a model, write some tests, get it out, it ships to production. There's a clear schema for it. This is all really great tooling, but the problem is monitoring and operating this at scale is still very, very difficult. And scaling with the size of the data team is just inefficient. And so now tools like Bigeye can help you ensure that your data is reliable when it has actually landed in the warehouse. But also now it's possible to make sure that whatever changes you're making to your models in dbt are actually going to be correct, and you're going to be able to ensure their correctness in the warehouse by comparing them to what you would expect production to look like. So let's talk about a little bit about the software product development lifecycle. So this is a slightly reimagined version of a diagram I found on a continuous deployment blog post. You have on the far left, you have Git. You're probably all using Git to check in your dbt models already. Git for software goes to a build, test, and integration pipeline. If everything builds correctly, tests are green, integration testing passes, then typically that artifact, the actual piece of software that is being built, gets put into QA, gets tested, goes into staging. Maybe this is beta for customers. Maybe this is internal staging only. And then finally gets promoted into production. And going back to the monitoring aspect of it, Datadog, New Relic, App Dynamics, tools like this are going to monitor production and then tell you that if your CPU utilization increases, if the latency of a specific endpoint increases, and they can connect that back to Git and say, by the way, this change caused an increase in your endpoint latency. You probably want to look into it. This might be a problem. And the whole cycle starts all over again. Now, this is a very robust cycle for making sure that bad things don't make it to production, to make sure that any piece of software that actually gets deployed is as good, as solid as it can be. But the data landscape looks a lot different today. In data, everything is production. You make a model change, you build it, you test it. There's no integration, there's no QA, there's no staging. We mostly just ship it to production. Now, if your data team does have these intermediate steps, does have integration testing, does have a staging environment, I applaud you. You're doing better than 90% of teams out there. But generally, the way that things operate is ETLs get changed straight in production, and things just go out, and we hope for the best, and we hope that none of the reports are broken and none of the downstream data products are broken from our changes. So this is my rough diagram of how data is deployed today. So let's say you're using dbt for building and testing. And the kind of testing that you're doing in dbt, I would consider unit testing in the software world. It's making assertions about the state of the world and then running it against your output and making sure that the assertion holds true. So you're probably doing things like null checks, you're doing your foreign key comparisons, and you might also be writing some custom tests, but those are still assertions. Make sure that this query will always return no records. Now, where's the difference here? Well, there's no real integration testing. Integration testing would assume that you take the final product and you simulate reality with it, and you say, how has anything downstream of this changed based on the new product? If your model in production is your existing product data output, how does my changed model actually cause a ripple effect through the rest of the system? What do my Tableau happens to my Tableau dashboards? What happens to my ML models? Or even simpler, how does the new version of my data model compare to the production version of my model? And a big reason for that is everything goes straight to production. There is no easy way for you to say compare staging to production. And once it is in production, things are just not monitored. Some teams are running Bigeye, some teams are running other tools for data monitoring or data observability, but this is not necessarily the common practice. And this causes a huge headache for data teams because now data teams have to think about manually have to think about what impact is my change going to have, and they are mostly reactive to problems as they come up. But what if I were to tell you there's a better way to do this? And the better way to do this is by separating out your new models from production. And the really key thing here is if data is a product, and we talk a lot about data products, then deploy it and treat its development like you would for software products as well. So the top of this chart doesn't change at all. dbt use it for build and unit testing. dbt is awesome for that. Add another layer of integration testing to make sure that you understand what is actually affected by your new changes. The best way to do that, have a staging or QA environment to validate that whatever changes you make aren't necessarily breaking changes. Bigeye can help with this with our deltas feature, which I will jump into in a couple of slides. After that, once you've validated that your changes aren't crazy, they're not going to break something or break some sort of assumption that you've had about your data all along, promote the new data set to production after it's been validated. Say, do an atomic swap of this is what is in production. Now the new data model is that is production code, and all changes are going to go through that. And then finally, make sure you monitor your data in production, because sure, you might not be making necessarily making any changes to your dbt logic and to your code, but if the data pipeline itself changes, if you are relying on data from upstream consumers, upstream producers, or third parties, they might be changing some sort of contract that your model doesn't necessarily account for. And without monitoring that production environment, you won't know that weird data is getting in there without you even having to touch it. So if we have this full-on integration environment, testing, QA, validation, and then promotion process, we can feel a lot better as data teams about what we are putting out there into production and make sure that it is reliable for our consumers, so for the people building dashboards on top of this, for the people building machine learning models on top of the data that we produce. And we can sleep more soundly and be much more proactive about finding these problems in the staging phase and before it affects anyone else, rather than being reactive to it once it's already broken in production. So let's now talk a little bit about how we even get there and how Bigeye can help you get there. So a lot of the features that I talked about in the previous slide already exist. So let's talk about the three major components of making a system like this actually work. Well, first off, let's talk about dbt Cloud. dbt Cloud already has an automatic way of creating staging environments with the GitHub plugin. And I'll show you a couple of screenshots as we walk through this. Bigeye Deltas helps you compare staging tables with production tables to understand how your changes are actually affecting your data. So you will know what has changed, and some of these changes might be expected changes that and the reason that you're updating your model, or they might be unexpected changes that you would need to go and address. And finally, you can orchestrate this all with GitHub Actions to make this much more seamless and not manual. And if you're not a GitHub user, GitLab has all of the same concepts. Anything, if you're using Jenkins, you have all of these same concepts, whatever build tool you are using here. So let's start with dbt Cloud. So staging tables through dbt Cloud. This is a couple of screenshots from our own Bigeye internal dbt environment. Whenever we create a new PR in GitHub, then dbt Cloud will actually create a whole new connection profile automatically for us in order to create a separate schema for us to go and make all of our changes to. So if you look below, this is the log output from dbt. You can see that these table models are going to a schema in our Snowflake environment called dbt Cloud PR 473081 product. And then there are table names, dim sessions, dim users. So this is an R production schema. This is a staging schema that was automatically created for me by dbt Cloud. There are a couple of posts out there about how to do this manually. If you're not using dbt Cloud, all of the functionality is there within dbt to create new profiles and override the targets, but dbt Cloud makes this all seamless, especially with the GitHub plugin, which just does this on each PR. So I know what changes happened in which PR. Great. So now I have a copy of what the new data is going to look like with my changes in a separate schema, which is now my staging schema, that I can now compare to production. In order to do this, what I'm going to do is I'm going to use Bigeye's Delta feature in order to go and compare two different tables and figure out which properties of these tables are different between the new and the old. Now, this is actually a screenshot of one of our users, Mayan Analytics. They have a case study up on our website. They use this exact process for their dbt management. They're using GitLab, and they have their own scripting around this, but the process is exactly the same, where every time they create a new change, they dynamically create a new Bigeye Delta to say, create a bunch of metrics on the old table and in production and the new version that is in my staging schema, and now run all of the Bigeye metrics and help me understand what is different between these two tables. And so you can see here, some of these are failing all of the metrics. Maybe it's an empty table because the change was bad. And some of them are passing everything. And then others are saying, well, there are some problems, there are some differences between production and staging. Now you can go and you can manually investigate this and understand what is actually happening with the new code changes, and why is it different from production, and is this something that I would expect or not. Then once you merge your change, you can get rid of this. This is as ephemeral of a object in Bigeye as the staging schema is with DBT, because once your PR lands, you can go and you can delete that DBT schema. Now, finally, you can wrap this all yourself. And as I mentioned, Mayan actually does wrap it themselves. We've also at Bigeye internally have played around with wrapping this ourselves. But we've also created a GitHub action that can help you get some of these things done much, much quicker. So GitHub actions are a way for you to orchestrate things that happen on PR changes, on either on merge to a branch, on PR open. And in this case, what you're actually seeing is a snippet of an action. It's a YAML config file that describes what steps need to be taken, that checks out our Bigeye Python SDK, actually installs our CLI, and then runs the Bigeye CLI to run the a CI/CD process on a specific YAML file. This is the Bigeye part. You can also, because DBT Cloud already handles my staging schema for me, all I really would need to do is wire the two together and make sure I understand which schema name I need to be running these changes on. This is all fairly doable through GitHub, and it makes it very easy for teams to say, great, as soon as there is a new version of a model up, as soon as there's a new PR up, go and automatically create the staging version of that model, create the Bigeye Delta, compare it to production, and then maybe there's a final step of report back to the PR all of the changes that there are. Or maybe you just want to manually investigate it, or you want to send it to Slack. You can do all of this with GitHub Actions and or manual investigation within Bigeye itself. So usually I'd pause here for any questions, but please come find me in Slack after the talk, and I'd be happy to discuss how you could get this set up in your own environment. So finally, what's next for a CI/CD integration pipeline? Well, there's a couple more things that we can do to make this whole thing better. First off, we can start testing end-to-end products and not just the models. I mostly focus this talk on testing DBT models. You make a change to a model, you need to make sure that that change has effects that are well understood and not surprises to anybody. Testing the end-to-end product would mean having maybe a copy of your whole Tableau dashboard or Looker dashboard, that if you're making a major set of model changes, there might be an easy way to automate making copies of the Tableau dashboard and then comparing the new dashboard relying on the new sets of data and staging against production. That would be very exciting. I know it's doable. We haven't gotten that far. Second of all, blocking releases on CI failures. So by default, none of this, what I'm talking about, is a blocking change. DBT tests are blocking. You can't publish a new model if DBT tests are failing. But if integration tests fail, there's nothing stopping you from going merge my PR anyways. I don't care. So that's something that you can introduce into your pipeline, is to block any changes going out unless Bigeye gives the all green, or unless there's some sort of manual intervention that says, yes, I expect this change and this isn't a problem. Third version of this is making a full copy of everything and then swapping it in. In this example, staging and the promotion that we do is by landing the model changes from DBT into main and then having them be applied on production. In reality, you could make a full copy of your whole DBT stack and then swap it live under the hood into production and do an atomic swap from one schema into another. It would be a much more holistic overview of what making sure you have a stepwise state change. And this is really where blue-green deployments come in, is if you can just say, I have a blue deployment, which is my production, and I have a new green one. Can I just atomically swap the two out and then repoint as necessary? And finally, the last improvement that I've already mentioned before is using Bigeye for monitoring production post-deployment. Make sure that all your production tables are monitored and there isn't anything unexpected going through your models because of third-party data changes, because your engineers changed how they log things, whatever it is. And Bigeye can be used for that as well as this integration testing that I've described. So finally, there's a bunch of Bigeye developer tools available. We just released, had an announcement about this a few weeks ago. So you can come check out a lot of our tooling that makes a lot of this automation easier, config-based monitoring, CLIs, operators, and SDKs that I've already mentioned a little bit before. Come talk to me and check out our website for more information here. Finally, thank you everyone for joining my talk. That's all I had. I am happy to take any questions, and I'm happy to take any questions in Slack, and I will answer all of them in the next 30 minutes. I'll be joining you in Slack. If you missed this talk, if you're watching this recording, if you're not on Slack, feel free to email me, igor@bigeye.com. With any questions or comments that you have, and I'm always happy to jam about how you could integrate this into the rest of your stack and build these sorts of integration processes into your data flow. Thank you, everyone.
Thank you for the great presentation, Igor. As you said, for the audience, if you would like to join the Q&A with our speaker, stay in the Coalesce Move Fast and channel on the DBT community Slack to submit your questions and comments. If not, the next sessions titled Beyond Pretty Graphs, How End-to-End Lineage Drives Better Actions and Navigating Data Consolidation After M&A will be starting at 12:45 p.m. CDT. And we hope to see you there. Thank you very much, everyone. Thank you, Igor.